Good morning, fifth graders. It's Mrs. SJ. Happy Monday. It is September 21st. I hope that you are doing well. We are starting off our math lesson this week considering, well, what in the world is a mixed number? How does this have to do with fractions? Before we get started, make sure you have some sort of writing utensil and something to take notes on and with. I highly recommend that you're using a math notebook to keep all of your ideas in the same place. It makes it easier when you are diving in and doing the math. Our teaching point for today, say it with me, right below, is I can define what a mixed number is, and I can add and subtract mixed numbers with like denominators. You know already how to add and subtract a fraction with like denominators. So consider, how might this be different than when we have done our adding and subtracting with fractions before? But before we get started, I really want us to do this first teaching point, which is I want us to be able to define what a mixed number is. So here I have just a few things for us to remind ourselves about. Well, a fraction consists of a numerator, which is a piece of a whole, and a denominator, which is the same amount of each piece. And really, to do adding and subtracting with fractions, we have to have a deep understanding of place value and how things progress and get bigger or smaller. And really, this is also going to come into play when we start to do decimals as well. Now, just to remind us, the numerator is the part, just one piece out of the whole, and the denominator represents how many equal pieces have been cut up within that whole, right? Now, a mixed number, when we're considering what a fraction is, well, I know a fraction exists between 0 and 1, and really a fraction is greater than 0, but often it is less than 1. Well, a mixed number is, and write this down, take notes with me. So to define what a mixed number is, well, a mixed number really is a representation. It represents of a whole number. Y'all know what whole numbers are, right? A whole number and a fraction. Let's say this again together. A mixed number is a representation of a whole number and a fraction. I drew this number line up here to consider that our mixed numbers are going to be greater than 1. And oftentimes we're considering, well, how can we quantify or represent what more than a whole number looks like, even with fractions? So we've got this definition. A mixed number is a representation of a whole number and a fraction. Well, I want to point out, you know whole numbers. We've done a whole great deal of work with whole numbers, especially whole numbers and understanding place value in 4th grade, in the beginning of 5th grade. You've been doing this work since really preschool for many of you. And now we're bringing fractions into this. So we're going to start with one mixed number, okay? Now the mixed number that I really want us to take a look at is, let's start off with 2 halves, okay? So if we have 2 and a half, okay? So this is going to be our first example. Now, if I'm drawing 2 and a half on a number line, right, this is going to have to be different. I might have to make a small, do 0 and maybe consider 3, right? 1, 2, and 3. Well, I know that 1/2 is halfway within a one whole, right? So if I was going to draw 1/2, it would be the halfway point of 1. But I don't just have a half, I also have the whole number of 2. So here's my 2, and here would be my 1/2. 2 and 1/2. Now, of course, there are other ways to represent this other than a number line. Remember, last week we talked about 3 different ways to represent a fraction. We talked about a number line. Consider, anybody else have an idea? If you're here and you would like to write in the chat, what are the other 2 ways that we can represent fractions? Well, we can represent a fraction with a fraction strip. And here, since I have 2 wholes, I'm going to need 2 fraction strips to represent that whole. And this last one, consider we don't have 3 wholes, but we do have 2.5. So with this last one, I am going to split it in half so that we have 2 wholes and a half. And to be able to properly represent this, I'm going to color it in to show the portions that we've used up. We have 1 whole plus 1 whole equals 2 wholes. And then I'm going to color in just a half to represent 2 halves. Now, I haven't seen anyone respond in the chat about the last way, but I'm sure many of you have already thought about it. We can also represent this with our circles, okay, and the pies. And so similarly with our fraction strips, I am going to need to draw 3 circles. Just like that final fraction strip, I do need to represent this fraction. And I'm going to do so by cutting it in half. And then coloring in the pieces of the whole that I have. 1 whole plus 1 whole equals 2 wholes, plus a half equals 2.5. So take a minute to look at the 3 different ways that we have represented this mixed number. I'm also going to put out there, oh, thank you, shout out to Ava, well done for sharing that we have our circle, our fraction strip, our number line as different ways to represent fractions. And now we know that we can use these not just to represent fractions, but we can also use them to represent what? Mixed numbers. Look at that. Now, this is really big. Some of you might notice that 2.5 can also be represented in a different way, but we're not there yet. We're going to move forward with our teaching point, and just to remind you, our second teaching point we want to look at is I can add and subtract mixed numbers with like denominators. So let's start with our addition. I'm going to give us 2 mixed numbers that we will be adding together, okay? Now, for those who need one more moment to write this down, take a look at it. If you need a pause, great, go for it. Otherwise, we are erasing it. Okay. Now, this next one that we're going to try out is a mixed number addition equation. And I want us to consider 1 3/4 plus 1 3/4. Well, many of you have already started this idea of understanding that, well, I can move these around. I know this is 1 3/4 plus 1 3/4, but I want to move this 1 over so that I can take a look at my fractions. And so really what you can do is I can say, well, I'm going to erase this and put the 1 right here. And I know 1 plus 1 equals, that's right, it equals 2, right? 1 plus 1 equals 2. Now I really have to consider how I'm going to add these 2 up. So I'm going to rewrite this so that it is very clear how it is set up. Notice that any whole number in front of a fraction, right? This part of having mixed numbers means it's mixed with a whole number and a fraction. Well, I know how to add up whole numbers. You know how to add up whole numbers. And also, you know how to add up fractions. Now, for those looking here, 3/4 plus 3/4. Well, the fourths are the same denominator. So that means we can add these straight across. But one thing I want us to be aware of is that, well, there's another whole in here. If I add up 3 plus 3, that gives me 6/4. Give me an agreement if that's what you got. Now the thing with 6/4 is that this is actually an improper fraction. And it's improper because there is a one whole in here that we need to take out and add to our other whole number. How do I know when a number is equivalent to one whole? How do I know when a number is equivalent to one whole? Well, for those of you who are thinking in your head, well, I know it's a whole, it's equal to 1 if the numerator and denominator are the same. Can we take out 4/4 here? Absolutely. This 4/4 also represents one whole. What am I left with if I have my one whole down here that I'm taking out? Well, 6 minus 4 is 2/4. I need to add this 1 to my other whole number, which is, so now 2 plus 1 is 3 whole, is 3 wholes. If I wanted to represent this visually, okay, because I'm doing a lot of math here, I'm going to take a step back and try and represent this visually, because this part can be real tricky. I've got some floating numbers down here. Okay, I've got this one whole that I took out of our 6/4, and I added it to this 2, which gave me 3. So now I have 3 and 2/4. Here's the thing though, I want to be able to represent this visually. So if I'm going to represent 1 and 3/4 plus 1 and 3/4, I'm going to draw this out. So the first thing I'm going to do is, and take a breath, I am going to erase this, but we are going to come back to show this thinking, but with a visual representation, okay? Well, let's set up our equations. I know I have one whole, and I know I have another 3/4, all right, which means I need to split this up into 4 pieces. And then I know I'm adding that up with another 1 and 3/4. And the way I'm going to represent that I have these whole numbers is by coloring it in. I have one whole and 3/4, which means I'm coloring in 1, 2, 3. 1, 2, 3. I also am going to show that I have another 1 and 3/4, and I'm going to make it look exactly like the top, because I know that it is 1 and 3/4 plus 1 and 3/4. 1, 2, 3. Well, I can take these one whole blocks and I can add them up together. So that means I have 2 wholes over here. Now, I also know I'm one more away of getting 1 whole. Is it possible for me to take away one of those fourths and give it to this 3/4 right here? Is that possible? If you're saying no, it's not possible, I want us to think about this. Well, I know that both of these are split up into 4 equal pieces, right? And they have the same denominator, which means that I can take one of these away and give it to my 3/4. So now, instead of 3/4, I have 4/4, which equals what? That's right, 1 whole. Take a look at how I did that. So now how many wholes do I have? 1, 2, 3. I have 3 wholes. 1, 2, and 3. Now I can't forget about this last fraction strip, can I? I can't. What is 2/4 equivalent to? 2/4. That is 2/4. What is 2/4 equivalent to? I'm going to give some think time in the chat and see if someone can help me with this. What is 2/4 equivalent to? Giving a good amount of think time here. What is 2/4 equivalent to? What is 2/4 equal to? Look at this. Look at how it's represented. This looks an awful lot similar to this up here. Can I simplify 2/4 to equal, oh, there it is. There it is, 1/2. Excellent job, Dermot. 2/4 is equivalent to 1/2. I can represent it either like this, or like this. It's still the same. 1/2 is 1/2 is 1/2. So in this instance, I want to simplify it, and I want to represent it so that this is showing me that I have 3 and 1/2. So let's review. 1, I'm going to erase this for a quick second because I want to show us exactly how the answer is written. 1 and 3/4, say it with me, 1 and 3/4 plus 1 and 3/4 equals 3 and 1/2. Look at how we represented this. Absolutely. So really what we were doing was we noticed that we could kind of subtract 1/4 from this 3/4 and add it to this one. So we added 1/4 to this 3/4 in order to get to there. On this note, and I'm going to give us a little bit more time just to take a look at this, of how we're representing mixed numbers. Now what I'm going to show is how to subtract mixed numbers. So I'm going to go ahead and erase this. If you need more time, you can always pause me. Absolutely. We are going to represent our thinking of subtracting fractions. So I am going to put our next equation up here. we are going to have 3 2 thirds minus 1 1/3. 3 2 thirds minus 1 1/3. Well, let's set this up using fraction strips. After listening to many of us in our small groups, I know that there are quite a few of us who really enjoy fraction strips. If circles are more your jam, go for it. I'm not here to tell you which strategy you need to use. I'm here to tell you that you need to figure out what strategy works best for you. If you're like me and fraction strips work well, run with it. So first, whenever we're subtracting a smaller number from a bigger number, right, whether it's a fraction or a mixed number or a whole number, we're always going to start off with this bigger number. So let's start off by drawing this out. Well, I know 3 wholes represent 3 whole fraction strips. I also know that I need to represent my 2 thirds by drawing a fraction strip that's split up how many times? Love it. Welcome. I'm seeing there's 17 of us here. I'm just curious, how many times do I need to split up this fraction? 3 times. That is correct, Amundo. Okay. So we have 3 2 thirds. Let's color this in to represent our mixed number. We know a mixed number is composed of a whole number and a fraction. It is a representation. Now, if I have 2 thirds, that means 2 out of the 3 parts are colored and filled in. 2 thirds. Okay. 1 1/3. We are taking away 1 whole and a third. Well, really, all I need to do is I can erase, right? Well, if I'm subtracting 1 whole from 3, I'm going to kind of rearrange this now. I'm going to go 3 minus 1. Okay. Now this looks kind of funny with an addition sign here, but then we're going to subtract 2 thirds minus a third. Well, 3 minus 1, you know this. What is 3 minus 1? It's 2, right? We know that. 3 minus 1 is 2. Now, and I can represent that by also just taking away 1 whole, right? I did it. I just took away 1 whole. Does this match this? Absolutely. We have 2 wholes. Now, if I take away 1/3, well, I know 2 minus 1 equals 1, right? If I take away 1/3, how many thirds are left? If I subtract 2 thirds from 1/3, I am left, look, with 1/3 left. So our answer for 3 2 thirds minus 1 1/3 is 2 1/3. This is our answer. Let's see if it matches our visual representation. Can we see 2 1/3 up here? Absolutely. So, what I would like for you guys to do at this point is finish taking down these notes. I am going to put a bonus up here for you to consider and work on for guided practice. And if you would like to meet me for our office hours in math, please meet me on our Zoom. Okay. All right, you guys, that concludes our math lesson for today. Say it with me. I can define a mixed number. A mixed number is a representation of a whole number and a fraction. Great. Say it with me again. I can add and subtract mixed numbers with like denominators.